Have you ever heard about building a wall when using limits? Watch the whole video to figure that out. Stay tuned. Hi guys, welcome to my YouTube channel Math Mastery. Today we'll talk about limits. Today we'll learn how to find limits from the right side and from the left side, and we will check if they are the same or not. As x approaches a certain number, what are the corresponding f of x values getting closer and closer to, right? So let's get started with that expression. If we have f of x is equal to 3x plus 2, the mediocre process, if we want to substitute x with 5, for example, it will be 3 times 5 plus 2. 3 times 5 is 15, and 15 plus 2 is 17. This is the normal process, right, for substitution. Now, what if we have another function like f of x is equal to x squared minus 1 divided by x minus 1? And if we wanted to substitute 1 for x, let's see. X squared minus 1 divided by x minus 1, when we substitute x with 1, it's 0 over 0. It's indeterminate. In fact, this is not really a solution. So let's look for another solution. In fact, the needs for limits come here. We don't know exactly what's happening at that point at x is equal to 1. So we can know what's happening around that point if x approaches 1 from the left and if x approaches 1 from the right. Look at the function here and look at the function here. They are getting closer and closer to a certain number, right? And this is the limit. Let me show you how that works. Now, back to this question. F of x is equal to x squared minus 1 divided by x minus 1. We know that the function is undefined as x is equal to 1, but we need to know what is exactly happening around x is equal to 1, because as x is equal to 1, the function is undefined. So we can select numbers around 1 from the right and from the left. Here 1.1 from the right, 1.01, and here 1.001. And from the left, 0.9, 0.99, 0.999. And we can use the calculator to save the time. Here's the function. And here, when x is equal to 0.9, y is equal to 1.9. And when x is equal to 0.99, y is equal to 1.99. And here, y is equal to 1.999. And from the right, x is equal to 1.1, y is equal to 2.1. And when x is equal to 1.01, y is equal to 2.01. When x is equal to 1.001, y is equal to 2.001. And as you see here, as x is equal to 1, the function is undefined. Now from the right, we see that as x approaches 1 from the right, we see that the function approaches 2. The first value 2.1, and then 2.01, and then 2.001. So as x approaches 1, the function is getting closer and closer to 2. This is from the right hand side. And also from the left hand side, as x approaches 1, y is approaching 2. So we can write down limit as x approaches 1 from the right hand side or from the right of f of x is equal to 2, right? This notation for limit stands for limit. And as well from the left, limit as x approaches 1 from the left of f of x is equal to 2. Now because the left hand and the right hand limits are equal, they are the same, so we can say that limit as x approaches 1 of f of x is equal to 2, and this is the answer. Let's try and solve this problem from the graph, and we want to check it will be the same answer or not. Now if you want to factor the numerator, you can do so. X squared minus 1 you can factor as x minus 1 times x plus 1 divided by x minus 1. Now x minus 1 and x minus 1 will be cancelled, so f of x equal to x plus 1, but you have a condition here should be mentioned. Why? Because the denominator shouldn't equal 0, so the denominator, which is x minus 1, so x minus 1 is not equal to 0, so x is not equal to 1. Now you can graph this function. F of x is equal to x plus 1. When x is equal to negative 2, y is equal to negative 2 plus 1, which is negative 1. And when x is equal to negative 1, negative 1 plus 1 is 0. And let's try a different number. When x is equal to 2, 2 plus 1 is 3. But remember, x is not equal to 1, so we will make a hole and then we will graph. This is the function. Now we want to find the limit, but the limit as x approaches 1, there are two limits. The limits from the left hand side and the limit from the right hand side. So as x approaches 1, when x approaches 1 from this side, from this direction, from the left hand side, approaches 1, let's see the function. The function is getting closer and closer to 2. It's not exactly 2, but it's getting closer and closer to it. So the limit as x approaches 1 from the left of f of x is equal to 2. What about the right hand side? If we are approaching 1 from the right hand side, look at the function. The function is getting closer and closer to 2 also. It's not 2, but it's getting closer and closer to 2. So we can say that the limit as x approaches 1 from the right of f of x is equal to 2. And they are the same. From the right and from the left, they are the same. So limit as x approaches 1 of f of x is equal to 2. And it's the same answer, if you remember, from the graph or from the table. They should be the same answer. And if you want to make it easier, you can draw a wall at x is equal to 1. Why x is equal to 1? Because we need to get the limit as x approaches 1. So draw a line or a wall at that point. And then we'll see, or we will trace the function from the right and trace the function from the left. Here, let's trace the function from the right. If you trace the function from the right, you will see that the function is getting closer and closer to the same number. It's getting closer and closer to 2. And from the left, it's getting closer and closer to 2 as well. So they are the same. So the limit is equal to 2. But if they are not the same, we can say that the limit doesn't exist. Another example. Here in this example, find the limit as x approaches 3 of f of x. Look at the function, or look at the graph here. You will see that 3, or the function at 3, there are 2 places at x is equal to 3. So we want to check the limit from the right and the limit from the left. Let's start with the limit from the left. Limit as x approaches 3 from the left of f of x. Right? So here, as x approaches 3 from the left, we want to trace the function. Trace the function. You will see that the function is 1. So limit as x approaches 3 from the left is equal to 1. But you can see here the circle is closed. That will affect the value or not? No, it doesn't affect the value. It doesn't affect the limit, because we want to check the function is getting closer and closer to what? But if the function is already here, so you can take it. The limit is equal to 1, right? So here is equal to 1. And now let's try the limit from the right side. When x approaches 3 from the right, trace the function. The function is getting closer and closer to 2. Now it's open, but that will not affect the value. So limit as x approaches 3 from the right of f of x is equal to 2. Now the limit from the right and the limit from the left, they are not equal, they are not the same. So limit as x approaches 3 from the left of f of x is not equal the limit as x approaches 3 from the right of f of x. So the limit as x approaches 3 of f of x doesn't exist. The limit doesn't exist. And this is the answer. Here in this example, find the limit as x approaches 4 of f of x. Here at x is equal to 4. It's clear that they are approaching the same number, but let's write down that in details. Limit as x approaches 4 from the left of f of x. Here from the left, as x approaches 4 from the left, trace the function. The function is getting closer and closer to 2. So the limit is equal to 2. Right? And here from the right, limit as x approaches 4 from the right of f of x. Now let's try as x approaches 4 from the right and trace the function. The function is getting closer and closer to 2. So the limit is equal to 2. And as you see here, they are the same number. The limit from the left and the limit from the right, they are equal. They are the same. So limit as x approaches 4 f of x is equal to 2. And this is the answer. In this example, f of x is equal to 1 over x minus 2. Find limit as x approaches infinity of f of x and limit as x approaches 0 of f of x. Now let's try graph the function. And by the way, this is a rational function. So we need to determine what is the vertical asymptote and the horizontal asymptote. Right? The vertical asymptote, just take the denominator and set the denominator equals 0. So x is equal to 0. This is the vertical asymptote. And the horizontal asymptote, take the other number, which is negative 2. So y is equal to negative 2 is the horizontal asymptote. Right? Now in the graph, x is equal to 0 is the vertical asymptote. Right? So here is the vertical asymptote. This is x is equal to 0. and here y is equal to negative 2. This is the horizontal asymptote. And the original function, which is 1 over x, is positive. So you will graph in the first quadrant and in the third quadrant. If it was negative, you will graph in the second quadrant and in the fourth quadrant. But here it's positive, so you will graph in the first and in the third. And this is the function. Now the first question is find the limit as x approaches infinity of f of x. So here, by the way, as x approaches infinity is just one side. The graph here is one side, because as x approaches infinity there is no other graph here. So as x approaches infinity, as x gets larger and larger in this positive direction, the corresponding f of x values approach what? Approach to this number. What is this number? Let's see. So the number is equal to negative 2. So the limit is equal to negative 2. Right? So the limit as x approaches infinity is equal to negative 2. And this is the answer. Now the second question, limit as x approaches 0 of f of x. As x approaches 0, here's the 0, so you have the two graphs. One graph on the right and one graph on the left, so you have to check the left limit and the right limit. Let's try the left limit first. As x approaches 0 from the left, the corresponding f of x values are getting closer and closer to what? Are getting closer and closer to negative infinity. They are decreasing without bound. So here the limit is equal to negative infinity. What about the right hand side? Here the graph, as x approaches 0 from the right, the corresponding f of x values are increasing without bound. So the limit is equal to infinity, and they are not the same. The left graph is equal to negative infinity and the right graph is equal to infinity. They are not the same, so the limit doesn't exist. And by the way, they are not the same and they are not finite. The limit as x approaches 0 of f of x does not exist. Right? So this is the answer for limit as x approaches 0. And this is the answer as x approaches infinity. I hope you enjoyed this lesson today. If you want to ask a question, don't forget to put it in the comments below. See you next time.